Well, hello friends. Welcome back to browser hacking. Today we're going to look at Wikipedia in the SerenityOS browser because it keeps improving. Our page layout keeps getting better, but we do have some pretty serious performance problems. So I thought we would make yet another one of those videos where we investigate why a page is drawing slowly. And then try to do something about it, see what we can learn. So as you can see, scrolling is pretty laggy. And my favorite test, just mousing over a bunch of links, you can quickly notice here that it's just really lagging behind the cursor. So we're gonna investigate that. But yeah, like look at page layout. It's really coming along. Still have some noticeable issues like text bleeding over the pictures and stuff like that, but getting there. So let's get a profile. That's what we always do. And I think I will just like hover spam over these links a little bit and then see what we can find out. All right. So let's just get a top functions view here. And we can see that we are in painting 94% of the time. All right. And we are in SVG geometry paintable 92% of the time. So seems like this page is dominated by SVG path filling. So the anti-aliasing painter, draw anti-alias line. And then we are really heavy in affine transform, which is the 2D transform that we apply to the path being rasterized. That's really heavy, actually. 25% of CPU time just doing that. So some SVG on this page somewhere is just killing us in anti-aliasing painter. And then we have, you know, like there's a tail here, but it's a tiny tail compared to SVG. We got like style update 2.75%. So completely irrelevant until we can get rid of the SVG issue. So I guess let's start with SVGs. First thing I want to find out is what is up with the transform. So there's a transform being used by draw anti-alias line. Okay. And it's this guy right here. Yeah, I remember this. I've worked on this code. Okay, so basically, every time that we want to draw or plot a pixel in the anti-aliasing line algorithm, we call this little function here called plot. We pass it the X and Y that we want to plot at, and there's also a coverage value, which we turn into alpha for the outgoing pixel. And everything, so the line algorithm just iterates through all of the points that we need to paint on, and then passes those points here, and then we transform those through the anti-aliasing painter's transform member. So we support an arbitrary transform on this guy. Right. So I guess we'll start by just printing out what the transform is. A line with transform. Okay. Then we'll see what kind of transform is in effect on Wikipedia. Okay, I don't remember the the order of what's what here. Define transform. There's a picture of it, of the matrix of what's what. Let's see. Is this the one I'm thinking of? I think so, yeah. So right, so an identity transform looks like this, and I think it's like goes like this guy, this guy, this guy, this guy, this guy, this guy. So zigzagging up and down, and then we ignore the bottom row. So the identity transform is 100100. And these two guys right here are the translation delta. So it's an identity transform with a Y translation, right? That's what it looks like to me. So that means that it's painting and then shifting the Y coordinate of every pixel minus 1000. And we are using the generic transform map function to perform a glorified translate, basically. We can definitely do less of that. It's something I've seen in many other rendering implementations. So I think that's a very reasonable thing to do. So I guess what we can do here is we can check, first we can check if it's an identity transform, because then we don't even have to transform the value. And then we can also check if it's a translation transform. And in those cases, only translate, but not perform scaling or skewing or like the full transformation, basically. We can probably avoid a lot of work that way. So how do we factor that? I guess ideally, whoever calls this would provide a transformation function, maybe. So something like type name transform point. Something like that. And instead of calling mTransform map, we would just do transform point. Okay. And then who uses this? Because it's templated in a C++ in a CPP file, so it's presumably it's only used within this file. Looks like that's the case. So that means that we can just add a transform point functor or whatever, or some kind of callable, and then we will pass that along here. So let's see. This is where it's called. Draw alias line or draw line. Okay, so there's already a templated variant for aliasing and anti-aliasing. Okay, so now we want to pass in something that can transform one point to another, depending on the transforming effect. So let's call it a full transform. If mTransform is identity, then we can do no transform, otherwise do a full transform. Or if it's identity, or if it's a translation, so translate transform. Okay, and then let's add a helper for that. So this translation, So wait, how do we know if it's a translation? I guess we know if it's a translation if these first four values are 1, 0, 0, 1. Okay. So 1, 0, 0, and 1. Yeah, if it starts like that, then it's a translation. I suppose it could also be an identity transform in that case, if the last two values are 0. But it's also a translation. So let's see. Translate transform. Okay, and then we would need some kind of a helper function here. So first one we wanted was no transform. Something like that. Actually, I guess we have to pass in the transform. And then we return x and y, and we actually don't need the transform for anything. Okay, and for the translate transform, we can do, let's see, so now we take, what was it, the last two, right? So x and y, the very last two, so e and y plus transform f. Okay. And if they say that they need the full transform, then we will just do transform map like that, or I guess like that. Okay, does this make sense? Let's see. Right, so if it's an identity transform, we pass no transform as the transform point function. If it's a translation, we pass translate transform. Otherwise, we fall back to full transform. And then we need to do the same thing down here. So it's really the same exact call, just with a different anti-alias policy. So what was it called? Full. Okay. Let's see. Too many arguments to function. Wait, what? Too few arguments. Okay. Yeah, right, because I wanted to pass the transform as well. Okay, so what is this going to get us? I think in the case where Wikipedia, clearly, they were just doing this transform right here. So this should allow us to do a simple translation on, we just translate the x and y coordinates instead of calling a transform map, because map does a lot more than that. It also does multiplications and just a generally more work, right? So let's find out how much less work we can do here. In fact, this makes me wonder, how is this transform actually mutated? Like, is it even possible to set an arbitrary transform, or do we, because it looks like we only have this translate API actually. So I guess we don't have an API yet to, that would even allow you to get into a situation with some arbitrary transform. But let's see how this fares. It's actually making me wonder if what if we didn't transform each individual point as it was coming in, but instead we put a transform on the underlying painter for the duration of the line that we're drawing. So then we could translate the painter once, and instead of doing this on every point. That might be an improvement on this. First, we just need to find out how much this gets us. Okay, well, that's going to take a moment. How can we improve this further? And what might it look like if we wanted to translate the painter? Also, do we need two separate branches for these two? Or could we just sort of fold them into a single, like is transform or whatever? Or is identity or translation? Because if it's an identity or a translation, we can just add zeros in the identity case. I suppose it's nicer to not add anything in the identity case. But we wouldn't need to add anything in the identity case if we translated the painter. So we already know that if something is a translation, if something is identity, then it will also be translation. Which means that in theory, we could do this as translation, and then we could, let's see, underlying painter, translate, I guess. And then translate by the transform E and transform F. And then just untranslate after painting. Like that. That's actually really interesting. But let's see if this gives us any kind of noticeable improvement in the first place. Definitely snappier, for sure. So seems like we're already on to something here. Let's get a bit of action. All right, mark this. Okay, so what are we looking at? Previously we had 93 or 92% or something like that. Now we are at 83% filling. That's really promising. And then we have 20% in translate transform. So that's less promising. But it already looked better. Like, I'm definitely seeing more underlines, so it's an improvement, but we can probably do a lot better still. Yeah, so the translate transform thing, what if we didn't need that? So if I've translated the painter, then I don't need to translate each individual point, right? Which means I can just use no transform, like that. Okay, let's try this. Full. Then I guess let's try it again. Should be a much faster rebuild since I'm not touching any headers. Okay. Okay, not sure if much better, but I'm interested to find out. Okay. Dun, dun. Let's see, so we're painting. Draw aliased line. No transform. So it's still there, but it's substantially less. See, no transform, 3%. I feel like we shouldn't need to have it at all though, since we're inlining all of this. So like, why does it actually become a separate thing that gets called? That's a bit weird. Maybe I need to say like always inline on these things. Okay. I mean, it's definitely a lot more responsive. So huge improvement already, but I'd like to get rid of that no transform thing as well from the profile. Like, why is that even showing up? Should get inlined. Still doesn't get inlined. Still doesn't get inlined, but but I'm calling a templated function. I wonder why it has to become its own function. Well, okay, well, I'm gonna try something. Let's just try to go 03. I remember having a similar problem with Graphics Painter, that it was also like not, yeah, you can see I've done the same exact thing here. In Graphics Painter, it was also like not inlining when I was trying to force something to get inlined, it refused to do it. And then I turned on 03 and then suddenly it worked. Let's see. Okay, well, the measurement is the real test, of course. Does feel nice. Definitely does feel nice. Okay. Nope, still there. Just imagining it. Okay. Well, now I'm just gonna, I'm not exactly sure why this is happening, so I'm just going to, I guess, try some random mutations to see if I can convince the compiler to inline it. So what if it just had out parameters instead? Like that, and then we didn't need to do anything. And I know transform works on floats, so let's do something like this. Wait. Maybe I don't need to do that. I don't need to return anything. I can just say yes and yes. Okay, and then this guy, instead of getting a return value, it would just do this. Okay. I mean, now I'm basically just doing voodoo to see to see if the compiler will inline it. I'm sure that there's some explanation for why it doesn't get inlined, but I'm not sure what that would be. Okay. Okay, now again, I hesitate to say that it feels faster because the profiler is ultimately going to tell us what the truth is. But it does feel significantly faster than last time, so is it my imagination? Or did this voodoo inlining work? It appears to maybe have worked. Okay, seems like that did the trick. Or at least it made the function so minuscule, since no transform does literally nothing. It's just a ret. What would it be like? No graphics, no transform. Yeah, so we don't have any samples in it anymore. Very cool. Okay, so let's take a look at the top functions right here. So SVG geometry paintable down from 93-ish to 79-ish. Definitely an improvement. Of course, still very heavy. And we should probably investigate what's going on with that. But at least we've improved this somewhat. So that's positive. Let's take a quick look at GitHub, because I know GitHub has SVG icons. I just want to make sure that I didn't break those. Not loading super fast, are we? Okay, well, the SVG icons are definitely showing up. Okay, why are we burning the CPU though? Who is doing that? I would really like to see the process table. Oh, okay, I'm getting a few of these. Oh, wait, look, it was request server. Oh, request server heating up the CPU. I haven't seen that one in a while. Okay, well, fascinating. What are you doing, pray tell? She's not going to tell us? All right. Well, this seems really nice. I think I'm going to rename this to is identity or translate, or is identity or translation. Because it could be an identity. Is not necessarily not an identity, right? So just to make it a little bit more accurate, is translation. Yeah, because doing a 0-0 translate in the identity case, it's no big deal. Yeah, I think that'll be really good. Okay, I just leave that building in the background. And then we'll say add affine transform is identity or translation. Okay, this will allow us to implement fast paths in cases where simple translation can be handled faster than a full complex, a full affine transform. Okay. See, anti-aliasing painter. How do we describe this? So, add fast path to anti-aliased line drawing with simple 2D transform. If the effective 2D transform is just a basic translation, we now simply translate the underlying painter before and after drawing AA lines. This avoids all the extra math that comes with fine transform map that otherwise has to happen when mapping points through an affine transform. Yeah, that's pretty good. This noticeably increases mousing around performance on Wikipedia. And I'm just going to put that O3 optimize in there, but maybe we'll wrap it in a compiler check pragma like Graphics Painter did. But I don't feel bad about specifically saying that please optimize the anti-aliasing painter with O3 just the same as we do for Graphics Painter. Use a slap an O3 optimization pragma on anti-aliasing painter. We're already doing this for Graphics Painter, so let's do it here as well. Okay. So what do we want to look at next? Also, I should make sure that other build finished. I guess one thing that we never really investigated was where is that SVG anyway? Also, the transform was a -1000Y translation. That's a little suspicious. Feels like they're like yanking something away from the page anyway. Let's see. Where can we see them? So we'll dump the DOM tree. We have an SVG right here. Okay, so let's look for SVGs. There's only this one. This is the whole SVG. And clip path? Wait, so this doesn't even draw anything. And the SVG is width 0, height 0. Wait a minute. So maybe we don't need to draw anything here. Let's see. So it's a clipping path that you can use with the clip path property. Sure. Okay. So I guess it means that, wait, how does this work? It means that it's something that can be referenced by a use element to bring in a clip and then apply that clip to something that you are instantiating with the use element. Okay. So let's see, what is there to unpack here? Well, thing number one, this is a 0 width, 0 height SVG, so it shouldn't be painting anything. So we should definitely have some kind of short circuit that makes this thing non-paint. And then we should also not paint should not try to paint clip paths. I think the problem here is that we don't know anything about defs and we don't know anything about clip path because we just haven't implemented those SVG elements. So I think what's happening here is that we see this SVG element and then we sort of go recursively through its descendants and then we're like, oh, here's a path. Ah, well, I guess we better render it. But if you look at it in context, you can see that it's a path used for clipping, not one for painting. So, let's put these paths into the path visualizer. There's this SVG path visualizer that's super cool. Over here, yeah, this is the one. So here we can see what they actually look like. So this one looks like that. Okay. Wonder what these are used for. Pop-ups SVG. So I guess these are used by some kind of pop-up on the page. Oh, it looks a bit like, oh yeah, I guess it does look like some kind of a tooltip pop-up or something. And it has this little notch here to indicate like who's giving the pop-up. Okay, so where do we start with this? I mean, now we spent all this time on trying to make AA lines through an affine transform go faster, which was not wasted time for sure, but because that'll benefit all anti-alias painting that only draws through a translate. Still, let's see if we can. I guess the first thing, we'll just check for the width 0, height 0, and not render. So we would have an SVG paintable. And what do we do when we try to paint one of these things? Before children paint, after children paint. Okay, so it doesn't do anything in particular when painting. So I guess the painting occurs in the geometry paintable. Okay, so an SVG geometry paintable basically takes a path, which can be a path of a basic shape like a rectangle or a circle, but it can also be a complex polygon. So it takes a path from the SVG element and then renders it. So all of these here will be represented by geometry paintables, which is itself a bug, basically, because we should figure out that there are clip paths, but even so. Let's see. SVG paintable. I think we shouldn't enter into one of these things if it is empty sized. So where would we do that? We have paint descendants. So, I'm just trying to think, like, what is the best factoring for this? Or if another better factoring would be to not make a paintable for these in the first place because of the clip path. Because it's not really a normal use case to make an empty sized SVG either. Let's see, what did the layout tree look like? We just only looked at the DOM, right? So the layout tree looks like It's convenient that it ends with the SVG. Okay, so this is our layout tree. We have the SVG box, this guy right here. And then if we haven't implemented an element, then we just turn it into inline nodes. So you can see here we get inline node for the defs, and we also get an inline node for the clip paths. And then they have SVG geometry box children for each of the path elements. So maybe, I guess we could make, one way we can approach this is we can implement some basic support for clip path, and then we can have clip path say that, oh, I don't want to be part of layout ever. And if we say that, then that will prevent us from even visiting its children during layout. And if they don't get laid out, they don't get painted either. Maybe that's the strat here. So, oh, I had it on MDN right here. Okay. And let's just add SVG clip path element, I guess. Clip. Yup. From the CSS masking module. I don't know if I've ever even opened this spec before. Oh, it's a pleasantly small thing. So let's see. Let's go ahead and add an IDL file for it. So libweb svg, no. Wait. Oh, there it is. SVG clip path element IDL CBP and H. And a little bit more busy work to also add to the CMake lists. So clip path element. I guess we can generate a wrapper for it. Why not? Okay. All right. Let's see if it's already part of our attribute names thingy. I think it needs to go in here. Clip path. Also, these should maybe be alphabetized. Yup. Okay. So we have this element factory function where all the elements go. It's been a while since I added an element, so just bear with me. SVG clip path element, right. Then where do we deal with all these things? I guess right here is fine. Clip path. Okay. And then it inherits from SVG element. Sure. So we'll put this into the IDL right here. And neither of these are going to be supported to begin with because I don't have these types. As far as I know, we haven't implemented any of these types before, so we'll just have an empty interface. But that's fine too. We can still add it to here though. SVG. Clip path element. Cool. Boilerplate. And okay, so now we have to actually implement some kind of a C++ class. So Let's see how this is going to go. It was supposed to inherit from SVG element. My cat is meowing at me, but I'm not able to help you right now, sweetheart. Okay, so it's going to be SVG clip path element, public SVG element. And I guess it doesn't really have anything private at the moment. Well, we'll just add some basics like this. The key thing here is to make sure that it does not create a layout node. So layout node, we have to override create layout node. I forget what the signature is. It's this thing right here. Okay, so create layout node. Override. Yeah, that's the important thing. So I think this is all that we need. And not forget pragma once. All right. Clip path element. Okay, sure. Super interesting. Oh, this one is going to be super interesting because we're just going to say, nope, no layout node for me. Please, thank you very much. Okay, and then the document and qualified name. We're just going to pass those along to our base class, which does the same thing. So we'll just do that too. Yeah. Okay, pass them up the chain. Great, 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 great. Will it work? I wonder. Oh, I didn't do anything to set up the wrappers, which means that the build is really small. So maybe we can get away with just testing it without the wrapper stuff. I guess I would still like to do something about the width 0, height 0 SVG case, but if we can just not generate layout nodes for clip paths, that would be a great start already. So let's see what happened here. Dump the layout node, nothing coming out. Oh, there we go. No, we're still getting them. So clip path. Did we make an SVG clip path element though? I wonder. Let's verify not reached if we get there, because I wonder if we do. I am immediately suspicious of the uppercase P in the tag name because SVG has some tag names with like an uppercase character in them, which I could imagine is probably going to mess us up somewhere, because I think we normalize tag names to all lowercase, maybe even earlier in this function actually. Yeah, right here. So that's not great. Okay, so how about we weasel our way out of it with this fix me. Support SVG's mixed case tag names properly. Yeah, so let's just weasel our way out of it for now by doing a caseless compare. But we're going to need that for some other elements as well, like SVG's foreign object element, for example. which is a bit annoying. But it will improve our engine to fix that correctly. Right now, though, I just want to... Okay, wait, what happened now? A crash. Oh, right. That's the verify not reached I added. Excellent. So we are instantiating the clip path element now. Okay. And let's see if it is consulted and honored about whether we should have a corresponding layout node. Clook. And look at that. They're gone. The path nodes. No more paths in our layout tree. Which then makes this ultra super fast. Now it's like, if you look at the CPU graph, you can see it's not even going over 50% when I do this. Oh yeah, that is much nicer. So we started out with optimizing something that was completely unnecessary, made some progress on that, and then got rid of the unnecessary thing, and boom, even better. That is really good. Wow, it doesn't even become like this big worm of samples anymore. So if we look at it now, what do we see? Well, like the anti-alias painter is all gone, of course. And now we see painting at 30%. And it's like a healthy mix of things, just recursively painting the page, sure. Style updates at 17%. See, now it's starting to look like any other web page instead of something just completely killed by that SVG thing. So that's great. Very, very good. Oh, yes. Now, I didn't finish up making it wrappable. So making it wrappable basically means that it becomes visible to JavaScript. So let's be good boys and take care of that as well. But it does mean we have to add it to some headers, which will induce a full libweb rebuild. Oops. Clip path element, sure. And then we also need to say using wrapper type, something like that, right? Yeah. Bindings, SVG clip path wrapper. Wait, is that not what I just added? No, it was not. Okay. So, what do we have here? Yeah, let's see. So, adding these files. Yes. Okay, so let's write a nice commit message about this. libweb sketch out a very basic SVG clip path element. This element doesn't actually support anything at the moment, but it still massively speeds up painting performance on Wikipedia. How? Because we no longer paint SVG path elements found inside clip path elements. So SVG clip path element create layout node returns null putter, which ensures that which stops the layout tree builder from recursing further into the subtree and so the path element never gets a layout box. Layout or paint box. Yes. Mousing over Wikipedia now barely breaks 50% CPU usage on my machine. That's super cool. That is super duper cool. I'm super happy with that, actually. Because I guess I really thought that that like once we had the first optimization to do like faster translation only transforms, I thought that, okay, well, that was the low-hanging fruit, and now we need to come up with something clever. But it turns out, as is often the case, we could just do a lot less work. So that is great news. And actually, we should double check on GitHub once again, just to make sure that we're not breaking the SVG icons that they use. GitHub is a nice place to check that. Oh, look at the scrolling. Oh, yeah, SVG icons are still here. They're a little bit imperfect. Our path rendering code still needs some love. It's better than it's ever been, but it's still looks a bit glitchy. But yeah, clearly still works. Resize could be faster, a lot faster, but at least painting is now super duper fast compared to where we started. Kick ass. And just to verify that I actually hooked up the JavaScript element. Oh, what happened there? Let's see if we have window.svg clip path element. Yes, we do. Bueno. Okay. So maybe just one little profile before we go. Just a profile. Oh, look at them. They're so fast. It's so beautiful. This is some of the most satisfying stuff ever, to take something that's insanely sluggish and then just make it super fast. One of the greatest feelings in the world. So, oh wait, I need to turn that upside down. All right. Yeah, so we got style updates, which of course are going to be heavy. What are they doing most of the time? Are they matching selectors? Doesn't look like selector matching is super heavy. Collect matching rules 16% in selector matching, so not the slowest thing in the world, but also not the fastest. Room for improvement, but it seems like paint is, yeah, we can definitely improve painting still on this page. A big area that we are not very good at all yet is to not paint stuff that's not visible. So even when we're painting this frame right here, we still go through content further down on the page and just paint it into a clipped painter. So it gets, I mean, it doesn't generate any pixels, but it's still like a lot of wasted work visiting all of those nodes. But there's some tricky parts to getting that right, because you have to take stuff like CSS transforms into account when determining if something is visible or not. So, but it's an area where we can definitely recover even more time and make this even faster, maybe even I guess the dream would be that we could scroll and hover on this page and you wouldn't even see a pixel of green on the CPU graph. Imagine that. It's going to take a while to get to that though, but it should be doable. Maybe. It's good to have ambitions. Okay, so I think this is going to be it for today's video. So if you made it this far, then I thank you for watching, for hanging out. I hope that you saw something interesting here. I certainly really enjoyed doing yet another one of these videos. It's possibly my favorite format ever. And it's just so nice to see our little browser maturing, growing up, and getting more correct, and also sort of slowly but surely improving performance towards something that you might actually be able to use one day without being super frustrated. Yeah, so thanks for hanging out, and I will see you all next time. Bye.